Imagine going to sleep tonight. And while you're dreaming, you've got this invisible, highly autonomous employee who is just wide awake.
Right.
And it's quietly redesigning your entire company's workflow. I mean, it's rewriting code, it's reallocating budgets, answering client emails.
Yeah, doing the heavy lifting.
Yeah, exactly. And then you wake up, you grab your coffee, and your job is just fundamentally different than it was the day before.
It sounds totally made up.
It does. It sounds like a pitch for a sci-fi movie, but that is literally just a Tuesday in the modern workplace.
Yeah, it's happening at this really staggering pace.
Yeah.
And we've moved so far beyond the traditional software update, you know?
Right, where you just click a button and the interface gets a little sleeker.
Exactly. You click update and then go back to doing your job exactly the same way. That era is over.
And look, if you are taking this deep dive with us today, you're probably feeling that whiplash because AI is everywhere.
Oh, absolutely everywhere.
But the conversation around it is just exhausting. It swings between this breathless, utopian hype and then total doom.
It's very polarized.
Right. And you just want to stay sharply informed without drowning in the information overload. You want to know what's actually going on beneath the surface.
Which is exactly why today's source material is so crucial. We are diving into a comprehensive research synthesis by Jonathan H. Westover, Ph.D.
It's a fantastic paper.
It really is. It's titled The Evolution of Artificial Intelligence, From Large Language Models to Superintelligence and the Transformation of Work.
So the mission of this deep dive today is to cut right through all that noise. We're going to map out the exact evolutionary stages of AI.
Step by step.
Yeah, step by step. But more importantly, we're going to look under the hood to understand how this technology is permanently rewiring the way we work, how we learn, and honestly, how we structure our organizations.
And what elevates this particular paper, what makes it so important, is that it relies on hard data. It doesn't just theorize about some distant future.
Yeah.
It pulls from early corporate deployments across professional services, healthcare, manufacturing.
So it's actual reality.
Exactly. It moves us past those tired philosophical debates and just grounds us in the reality of what is happening on the front lines right now.
Which we desperately need because, I mean, I hear these terms thrown around constantly. Agentic, multi-agent, LLM.
Right, it can be a lot of jargon.
Yeah, and for a lot of people, it all just looks like a chatbot on a screen.
Just a text box, yeah.
So, but before we can understand how this changes our careers, we have to understand the mechanics. Like, how are these stages actually different?
It's a critical distinction to make because AI is not a single monolithic thing.
Right.
The paper breaks it down into this evolutionary ladder with very distinct architectural stages. And every step up that ladder represents this massive leap in autonomy.
It completely changes how humans and machines interact.
It does.
So let's walk through those first three stages because this is what we're all wrestling with right now.
Okay, let's do it.
So stage one is large language models, or LLMs. This is your GPT-4, your Claude.
The ones everyone knows.
Exactly. Then stage two takes a step up, agentic AI, and then stage three is multi-agent AI.
Right.
Let me try out an analogy here to see if I'm grasping the mechanical difference, because it really comes down to autonomy, right?
Exactly. It's all about how much you have to hold the system's hand.
Okay, so think of an LLM like a brilliant but entirely literal-minded intern.
I like that.
Like this intern knows everything, but they cannot do anything unless you stand there and hold their hand. You have to prompt every single action. That's stage one.
Yeah, a highly capable but fundamentally reactive system.
Right. Now, stage two, agentic AI, is like giving that same intern, well, actually, no, it's like an experienced employee. You give them a project and walk away.
They can actually execute.
Right. You just say, write this report. The AI hits a roadblock, it uses tools to solve it, maybe searches the web, and it has a working memory of what it just did.
That is the perfect way to visualize it.
Yeah.
The system can iterate.
It can try again.
Exactly. Think of an autonomous coding assistant. It writes the code, tests it, sees the error message, and then autonomously rewrites the code until the test passes.
You weren't even in that loop.
You're not. And then we get to stage three, multi-agent AI.
So following my analogy, this isn't just one employee. This is like outsourcing to an entire virtual department.
Yes. You have a specialist AI acting as the researcher, another as the writer, and a manager AI coordinating them.
All talking to each other.
They are communicating, negotiating, and collaborating, all without you intervening. The jump in complexity there is staggering.
It's wild.
But, you know, what's fascinating here is where this trajectory ultimately leads.
Uh-oh.
Because those first three stages, the ones we're dealing with today, They're just the beginning. The paper details two final theoretical stages:
Okay, brace yourself.
artificial general intelligence, or AGI, and superintelligence.
AGI, the buzzword that just terrifies and excites everyone at the exact same
Oh,
time.
absolutely.
What is the actual threshold for AGI, according to the research? Like, when do we actually hit it?
So AGI is the point where an AI system matches human cognitive flexibility across virtually all economically valuable tasks.
Cognitive flexibility.
Yes, that is the key word. Right now, AI is narrow. It does one thing well. AGI would transfer learning across completely different, unrelated contexts.
Just like a human brain does.
Exactly. Like how you learn to play chess. And those strategic principles help you, say, negotiate a business deal. AGI would do that.
And I imagine the timeline for hitting that threshold is just fiercely debated.
Oh, highly debated. But the paper points to surveys of AI researchers showing median estimates for AGI development landing somewhere between 2040 and 2060.
Wow, so within our lifetimes.
Very likely. And the critical thing to understand is that if AGI is achieved, it acts as the immediate stepping stone to superintelligence.
Which is when the machines are just flat out smarter than us in every domain.
Yes, but the mechanism of how it gets smarter is what really matters. Superintelligence would be capable of recursive self-improvement.
Meaning it upgrades itself.
Exactly. It would analyze its own source code, identify inefficiencies, and upgrade its own architecture over and over again,
Just snowballing.
potentially accelerating its capabilities at a speed far beyond human comprehension.
I mean, it's genuinely dizzying to think about. And I want you, the listener, to just take a second and ground yourself here.
Yeah, take a breath.
Reflect on which stage you are interacting with in your daily life right now. Chances are you're mostly using LLMs, maybe dipping your toes into some early agentic system.
Well, you aren't alone in this. The paper notes that 72% of organizations have already deployed generative AI in at least one function.
72%, which means this transition isn't coming, it is already here. We're living in the thick of stages 1 and 2.
Really are.
Okay, let's pull this down from the theoretical clouds and look at the ground reality.
Good idea.
If we are currently living in this LLM and early agentic era, and 72% of companies are using it, my immediate question is, are we all just instantly doubling our productivity?
Right, the golden question.
If I give my team this tool, do we just get twice as much done?
Well, the vendors selling the software certainly want you to believe that.
Of course they do.
But the empirical data paints a much more complicated and, honestly, a much more dangerous picture.
Dangerous. Okay, let's unpack this. Because I was looking at this massive case study from the Boston Consulting Group cited in the text.
Oh, the BCG study, yes.
Yeah, they took 758 of their own consultants and had them use GPT-4. And for basic tasks, things like ideation, brainstorming, the results were exactly what you'd hope for.
Very positive.
The consultants saw a 25% increase in speed and a 40% boost in quality.
I mean, on paper, that is a massive victory. Any executive would look at those numbers and just immediately mandate AI adoption across the whole company.
But let me push back there, because there is a shocking flip side to that exact same study.
There it is.
For tasks that required complex judgment, specifically problems that fell just slightly outside the AI's training data, the consultants who used AI actually performed 19% worse than the ones who didn't use it at all.
19% worse.
I am struggling to understand the mechanism here, because if I use a calculator, I don't suddenly get 19% worse at math just because the numbers get bigger, you know?
Right.
How does a tool that makes you 40% better at one thing simultaneously degrade your performance on another?
Because a calculator is deterministic. It gives you the exact same answer every single time.
Okay.
An LLM is probabilistic. It is just guessing the most likely next word. And this leads to a psychological trap the paper brilliantly describes as competence without comprehension.
Competence without comprehension. Explain how that trap actually works in the human brain.
Well, when a human uses an AI, and the AI provides these brilliant, flawless answers 80% of the time, the human brain gets lazy.
We just start trusting it.
We are wired to conserve cognitive energy, so we start to blindly trust the machine for the other 20%. The consultants performed 19% worse because they accepted the AI's subtle errors instead of doing the hard work of verifying the logic.
Oh, wow. That makes a lot of sense. The machine sounds so incredibly confident, even when it is completely wrong.
Exactly. Let's look at another real-world example from the text that illustrates this perfectly.
Yeah.
A pharmaceutical company piloted agentic bots to conduct literature reviews, basically reading thousands of medical papers to summarize findings.
Which takes humans forever.
Exactly. and the bots successfully and fully automated 70% of the workload.
Which, again, sounds like a massive win for the pharma company.
It does, until you examine the remaining 30%.
Hmm.
The bots didn't just fail by spitting out obvious gibberish.
What did they do?
They hallucinated subtle, highly plausible-seeming errors. The output looked exactly like a professionally written, accurate scientific summary.
So a human scientist reading it wouldn't just immediately spot the mistake.
Precisely. And this creates a massive, hidden bottleneck. The human scientists are no longer doing the base research, sure, but now they have to painstakingly fact-check and verify every single claim the AI wrote.
Oh man, cross-referencing it against the original text.
Yes. The human role fundamentally shifts from creator to expert verifier.
And honestly, the cognitive friction of editing someone else's confident-sounding text is often way higher than just writing it yourself from scratch.
It's exhausting.
You might save time on the drafting, but you lose it all in the editing phase.
And this leads to a sobering financial reality that completely disrupts the ROI models companies are building right now.
How so?
The paper cites a financial services firm that deployed an LLM tool. They discovered that for every $1 they spent on the actual AI software licensing,
Okay, $1.
they had to spend $2 on integration, workflow customization, and ongoing human oversight.
Wait, are you saying the cutting-edge artificial intelligence is actually the cheap part of the equation?
By far, it is a 3-to-1 total cost of ownership ratio. The real expense isn't the software subscription.
Right.
The real expense is the sheer amount of human labor required to babysit the software, catch its subtle hallucinations, and redesign your entire workflow to accommodate it.
So if companies are spending $3 to babysit the AI for every $1 they spend on the tool itself, that completely shifts what it means to be an employee.
It fundamentally changes the job.
Yeah. If the bots are increasingly doing the basic foundational work and the humans are just left staring at a screen waiting for a machine to hallucinate so they can fix it, what does that do to human psychology over time?
It's a huge issue.
What does it do to career growth?
It completely shatters the traditional professional life cycle. We are seeing a massive skill recomposition.
The occupational data in the paper is wild. It points out that right now, fewer than 5% of occupations face full, total automation.
Right, so the robots aren't just taking everyone's job outright.
Exactly. That idea isn't accurate, but the tasks within those jobs are changing, and it is creating what the paper calls the missing rung problem.
This is perhaps the most urgent insight in the entire synthesis for anyone currently in the workforce.
So, if you're listening to this and you manage a team, or even if you're just managing your own career, ask yourself, how did you actually get good at your job?
You practiced.
You probably started out doing the grunt work. You drafted the basic reports. You wrote the boilerplate code. You did the initial research. You learned the fundamental mechanics of your industry by doing routine tasks.
But if AI is suddenly hyper-efficient at automating all that routine entry-level work, the bottom rung of the career ladder just vanishes.
Exactly. If we outsource all the junior level practice to an agentic AI, how do we ever create senior experts?
You can't.
Where do the brilliant senior partners of tomorrow come from if no one is allowed to be a fumbling junior associate today? You can't just spawn a 10-year veteran out of thin air.
If we connect this to the bigger picture, we don't even have to guess how this ends. We can look at industries that have already undergone intense automation.
Like what?
The text draws a direct, sobering parallel to aviation and modern manufacturing.
What happened there?
In those fields, when human roles devolved into passive monitoring, when the job became just sitting in a chair, watching an automated system work, and waiting to catch a rare error, it led to extreme cognitive fatigue.
Because watching a machine do a job requires a completely different type of brain power than actively doing the job yourself.
It's so much harder to stay focused.
It's incredibly tedious to maintain high vigilance for hours on end when nothing is happening.
It causes immense stress, a measurable loss of vigilance over time, and honestly, a profound loss of pride in craftsmanship.
That makes total sense.
The paper highlights a survey of knowledge workers dealing with heavy AI integration. These highly educated professionals described feeling actively de-skilled.
Wow.
They started referring to themselves as mere button pushers. This isn't just about corporate efficiency. It is an existential shift in how human beings derive meaning and satisfaction from their labor.
And I imagine this shift isn't hitting everyone equally. Who are the winners and losers here?
Well, there is a massive distributional equity concern. Currently, AI heavily favors high-skilled workers and large, well-resourced firms.
Okay, give me an example.
The paper gives a great example of a paralegal. A senior paralegal who already possesses deep foundational legal knowledge can use an LLM to dramatically speed up their workflow.
Because they know what they're doing.
Right. They can take on complex client advisory roles, effectively elevating themselves into a highly paid strategic advisor. They thrive.
Because they have the expertise to instantly spot when the AI is hallucinating a fake court case.
Exactly. But the junior paralegal, the one who doesn't have that foundational knowledge yet and relies on doing the basic summaries to learn.
They're stuck.
They can't catch the errors, so they aren't trusted to use the tool, and eventually they just get pushed out entirely. The technology polarizes the workforce, hollowing out the middle.
So let's tally up the risks here. We have the threat of de-skilling, severe worker burnout from passive monitoring, the missing rung on the career ladder, and widening economic inequality.
It sounds bleak when you list it all out.
It really does. If that is the reality on the ground, what is the actual playbook? How are smart organizations navigating this transition without utterly destroying the morale of their workforce?
The good news is that this isn't a hopeless situation. The paper outlines very specific evidence-based solutions from organizations that are actually getting this right.
Oh, thank goodness.
It just requires a level of intentional design that most companies aren't used to.
Well, let's hear the playbook, because anyone listening who leads a team needs these strategies today.
Let's start with Deloitte.
Hmm?
They needed to implement AI across their audit practice, which is highly complex, regulated work.
Right.
Instead of just buying a tool and forcing it onto the team from the top down, they used a framework called participatory design.
Wait, how does that actually work in practice? Do the auditors literally sit down and write the code for the AI?
Not writing the code, no, but co-designing the workflow. They brought the auditors into the development process and asked, where are your bottlenecks? What specific tasks should the AI handle? And where must a human make the final call?
So they're building it together.
Because the workers contributed their domain expertise, they understood exactly where the tool's boundaries were. As a result, Deloitte saw a 30% higher adoption rate.
That's huge.
The workers didn't feel replaced. They felt like they had commissioned a custom tool to make their own lives easier.
That makes complete psychological sense. You buy into what you help build.
Exactly.
But what about situations where jobs actually are on the line, where the AI really is replacing human headcount?
That is where Salesforce provides a masterclass. They integrated powerful LLM capabilities and faced a harsh reality. They needed 20 to 25% fewer entry-level customer support reps.
Ouch. Which is terrifying for those reps. That is exactly the missing rung problem playing out in real time.
Absolutely. But Salesforce did something crucial. They made sure the process of transition was radically transparent and fair.
How so?
In organizational psychology, there is a term for this, procedural justice. It is the idea that even if an employee doesn't like the final outcome, they respect the fairness of the process.
So what did procedural justice look like for a Salesforce rep whose job was just automated?
Instead of immediate layoffs, Salesforce proactively funded retraining programs. They guaranteed internal interviews for new roles in different departments, like customer success and tech sales.
Oh, that's smart.
Because they handled it with total transparency and actually invested in their people's mobility, they successfully transitioned 68% of the affected workers into new internal roles.
Wow, 68%.
And even amid the stress of automation, internal surveys showed workers felt the company treated them fairly.
There's an example from Accenture in the text that absolutely blew my mind regarding financial incentives.
Yes, the billion-dollar investment.
Right. Accenture invested $1 billion into AI over 3 years, and they offered massive retraining stipends between $5,000 and $10,000 per employee.
Which is incredible on its own.
It is. But the detail that stopped me in my tracks was how they handled the financial upside. They actually tracked the productivity gains generated by the AI and distributed 15% of those gains back to the specific teams as profit sharing.
It is a brilliant move because it fundamentally rewires the incentive structure.
Yeah.
Suddenly, the AI isn't an existential threat to your livelihood. It is a direct driver of your own personal bonus. You want the AI to succeed because you get a cut of the efficiency.
Okay, but here's where it gets really interesting. There's an example that goes entirely against the grain of typical business logic.
The Microsoft case.
Yes. We always talk about making software faster and more seamless. But the paper details Microsoft's responsible AI deployment for a code completion tool. They rolled it out to developers, but their internal human impact assessments showed that the AI was actually hurting junior coders.
Because it was doing the work for them.
Exactly. It was giving them the answers instantly. It destroyed their opportunity to struggle with a complex problem, which is how humans actually learn.
So they had to pivot.
So, what did Microsoft do? They intentionally crippled their own software. They deliberately redesigned the AI to provide progressive, delayed assistance.
It is an incredible counterintuitive strategy.
They literally made the tool slower. If a junior dev asked for help, the AI would only offer a minimal hint at first. It forced the human to put in some effort and try to solve it.
To actually think about it.
Only after the human struggled would the AI offer a bigger piece of code. They actively compromised on raw speed and efficiency to preserve the human's opportunity to learn. I cannot imagine the fight it took to get executives to agree to make their product artificially worse just to save the missing rung.
It perfectly illustrates that short-term productivity cannot be the only metric we care about.
No, we can't.
If you optimize purely for speed today, you bankrupt your talent pool tomorrow. We also have to look at how we train humans to work alongside these systems. Siemens built an AI academy and put 300,000 workers through it.
How do you train 300,000 people to use a tool that is constantly changing, like the interface changes every week?
Well, you don't teach them which buttons to press. You teach them how to think.
Ah.
Siemens focused heavily on training workers to critically evaluate AI hallucinations. They taught them the mechanisms of how LMs fail, how to look for logical inconsistencies rather than grammatical errors.
So they're teaching skepticism.
Exactly. They explicitly trained their workforce to be skeptical of the machine. And the results speak for themselves. The business units that went through this critical thinking training experienced 34% fewer AI-related quality incidents.
That's a massive drop.
They proved that human critical thinking is the ultimate indispensable safety net.
When we step back and look at the whole arc of this deep dive, from a paralyzed sous chef LLM all the way up to the theoretical heights of an AGI that can recursively improve itself, the big takeaway is incredibly clear.
It really is.
The AI transition isn't just a question of what we can automate. It is a profound philosophical question of what we should automate. We cannot just deploy this technology and hope for the best.
Hope is not a strategy.
No. It requires incredible intentionality. We need continuous learning sandboxes, we need to co-design workflows with the workers, and we need a fierce, uncompromising commitment to preserving human agency.
And this raises an important question about how we prepare for what comes next.
Right.
Preparing for artificial general intelligence doesn't mean panicking about science fiction doomsday scenarios. It means doing the very unglamorous hard work today.
The groundwork.
It means building ethical frameworks right now. It means setting up governance teams right now. And most importantly, it means training humans in durable, resilient skills that AI cannot easily replicate. Skills like systems thinking, cross-cultural empathy, and high-level emotional intelligence.
That's the fundamentally human stuff.
If we build those critical muscles today while we're dealing with agentic AI, we will be ready for whatever AGI brings tomorrow.
I want to leave you, the listener, with one final provocative thought to mull over. We started this conversation talking about AI, like hiring a highly autonomous employee who redesigns your company while you sleep. But let's take that trajectory to its absolute logical extreme. If we truly are heading toward a future of artificial general intelligence and eventually a superintelligence that can recursively upgrade itself without any human intervention, the very definition of what we call work is inevitably going to shatter.
It will be unrecognizable.
If a machine can eventually do every single economically valuable task better, faster, and cheaper than a human being ever could, what becomes the ultimate purpose of human education?
Wow.
For centuries, we have been learning primarily so we can produce value in a market. But if the machine produces everything, are we going to have to fundamentally rediscover what it means to learn purely for the sake of human flourishing?
It is the ultimate question we will have to answer.
It really is. Thanks for taking this deep dive with us.